Okay, so if we look at section 12.1, at a certain temperature, so for our case it's 18 degrees Celsius, at certain temperature we can figure out the velocity or the speed of sound, and that's gonna be 331, which is the speed of sound at 0 degrees Celsius. Then we'll have a factor of zero point 0.6, and then we multiply that with the temperature in Celsius, and then yeah, so that gives us the velocity of sound at 18 degrees Celsius. So if we calculate it, make sure the units are there. Yeah, so if we calculate it, it comes out as 341.8 meters per second. Now, if we go to figure 12.11a, we see it discusses about the organ open pipe, and the fundamental frequency for an open pipe is given by F equals velocity or the speed of sound over twice the length of the organ pipe. Now we don't know the length, but we know the frequency, and we know the speed of sound. So the frequency is this guy right here. So if we solve for L from there, we have something like this, and so it's V over 2 times frequency. So if we try to put all the numbers, we'll have 341.8 meters per second over 2 times the frequency, which is 262 hertz, and that gives us 0.652 meter or 65.2 centimeters. Right. So the second question says, what's the wavelength? What are the wavelength and frequency of the fundamental standing wave in the tube? Now, for the frequency, so since it's a open pipe, so we'll face standing wave there. So that's why the wavelength will be sorry, the frequency will be the frequency that's given. So for our case, frequency is nothing but 262 hertz, and for wavelength, we see it's gonna be twice the length of the organ pipe. So for our case, it's gonna be 2L, which is 1.3 meters. Right. So we get 1.3 from here only. So what we're doing is we're multiplying 0.652 by 2. So the way we are getting this is 2 times 0.652 meters. So that gives us 1.3. Now for part C, it says what are lambda, so what are wavelength and frequency in the traveling sound wave produced in the outside air. So we have to understand here that the wavelength and the frequency that are same in the air, because the air itself is resonating with the organ pipe. So outside air is resonating with outside air resonating with sorry. So the outside air or the air is resonating in the organ pipe. The organ pipe. So yeah, so that's why the wavelength and frequency, they will be the same. So right, so for our case again, frequency will be 262 hertz and wavelength lambda is going to be 1.30 meter. Thank you.